Hi everyone. Today we're going to continue to be looking at central bank policy and how it influences inflation. In the previous video, we used the Fisher equation to explain how in the long run, an increase in nominal interest rates will cause an increase in inflation. But in this video, we're going to try and explain how policy in the short run has an impact on inflation and how a central bank decides whether or not to raise nominal interest rates. The policy rule looks quite similar to the Fisher equation in that we have that the interest rate, the nominal interest rate, equals the estimated real interest rate, and we denote that it's an estimate by putting a hat over the R there, plus the target rate of inflation, the long run inflation target. So far this looks pretty similar to the Fisher equation. Not quite the same because we have an estimate for the real interest rate, and we also have inflation being the long run inflation target, not inflation expectations. But I'll show you how it's compatible in a minute. However, we're not quite finished here. So as I mentioned previously, in the short run, we allow for the fact that inflation may not be equal to the bank's target. And as a result of this, we include an extra term, which is that chi, which I'll come on to a second, is multiplied by the actual rate of inflation minus the inflation target. So this expression here is the degree to which the short run difference between the current rate of inflation and the target. Chi measures the sensitivity of the central bank to this difference. So the larger chi is, the more a off-target inflation will result in a change in interest rates. And just to recap here, we have the central bank's inflation target, long run inflation target. We have the estimated real interest rate. So the real interest rate, as we discussed in the previous video, is determined by the sort of marginal product of capital, determined by the real economy. But in practice, all we can do is try and estimate that. So the central bank tries to estimate what exactly the real interest rate is. And then, of course, we just have the nominal interest rate. So what are the implications of this policy rule for inflation? Well, if we look at this right-hand expression here, pi t minus pi bar, again, this shows the difference between inflation and the target rate of inflation. So what happens, and what the policy rule describes, is that when we have that pi t is greater than pi bar, in other words, that inflation is above the target rate. So for instance, we could say that if the target rate was 2%, if the economy was currently experiencing 3% inflation, we would be above target by 1 percentage point. So as a result of this, what would occur is that if inflation was too high, if you like, the central bank must raise nominal interest rates in the short term. Similarly, if we had that inflation was lower than the nominal interest rate, so maybe we had 1% inflation here versus a 2% target, then we would expect the central bank to be reducing nominal interest rates in the short term. Now this might seem a bit odd because in the previous video, in the Fisher equation video, we argued that an increase in interest rates in the long run will also result in an increase in inflation. But just to prove now that this policy rule is indeed compatible with the Fisher equation, we need to look at how the policy rule operates in the long run. So in the long run, the important difference to note is that it's not possible for inflation to be off target. The reason for this is because if the central bank's target is credible, then market actors, who we assume have rational expectations, will rightly expect that the central bank will achieve its target. So therefore, in the long run, there's no chance that the inflation target will be off. The inflation will be off target. And therefore, we have that pi t will always equal pi bar. Well, if that's the case, then we can rewrite the equation as follows. So in the long run, we have that the nominal interest rate equals the following. Now, if pi t equals pi bar, then that expression there is simply 0, so we eliminate it entirely. And then we're left with the following. Well, as we stated here, pi t must equal pi bar, so we have the nominal interest rate equal the real interest rate, the estimated real interest rate, pi t. And there we have the same conclusion as in the Fisher equation, that an increase in interest rates will cause an increase in inflation. And as such, we find that actually the policy rule and the Fisher equation are indeed compatible. It's simply that the policy rule operates differently in the long run because there's no possibility of off-target inflation. So that's it for today. In the next video, we're going to be looking at the Taylor principle, which is going to clear up a couple of unresolved issues about the policy rule. Firstly, we're going to prove the fact that an increase in interest rates in the short run will reduce inflation, again in the short run. And the second is going to prove why it's the case that we expect that chi will in general be greater than 1, which proves that the central bank will react very strongly to above target inflation.